Hey guys, my name is Trevor Sullivan and welcome back to my video channel. If you enjoy this video by the end, please like, subscribe, and make sure that you share a link with your friends, family, and professional contacts. In this video, we're going to be continuing our learning about LXD or LXD on Linux so that you can learn how to create virtual machines. Back in the first video where we introduced LXD for virtual machine infrastructure, we briefly touched on what images are, or operating system images that we can use to launch new virtual machines from. So we're going to spend a little bit more time on images specifically so that you can start to get a better understanding of how images actually work inside of LXD, how to get started with creating your own custom images based off of the publicly accessible images, and what kind of image servers are available for you to actually download images from. So the first topic of discussion is going to be around protocols for LXD remotes. Now, when you download a container image or a virtual machine image for LXD, you're actually communicating with a remote image server. So typically, you're going to be using the LXC CLI or perhaps some other utility like maybe the web user interface or anything that's compatible with the LXD engine REST API in order to perform commands against the LXD daemon, right? That's the engine or the service that's running in the background on your Linux host that's going to run virtual machines. Well, when you tell LXD to download an image or to launch a new virtual machine, which actually causes LXD to go out and download an image, it's going to go out and talk to an image server using a couple of different protocols. Now, there's two different protocols available for LXD when it comes to downloading images from a remote image server. The first protocol is called Simple Streams, and this is actually newer than the other protocol that we're going to talk about. But what's important to understand about Simple Streams is that it's designed to be publicly available. So typically you'd have an image server out on the internet with some very generic images, something that doesn't contain any proprietary company data or information or packages, and that image would then be publicly available through this Simple Streams protocol. And this is a more efficient protocol. It's a much more targeted protocol for downloading virtual machine images and container images rather than giving you full control over the LXD daemon. Now, one limitation of the Simple Streams protocol is that because of the way that the manifest data or the metadata is implemented on the server, it can be slower to actually do searches or lookups of images that are on a Simple Streams server. So just be aware of that, but most of the publicly available image servers that you'll be dealing with are actually Simple Streams protocol. Now, the other option that you have for the protocol is to actually simply talk to another LXD endpoint. So you could actually have a LXD host somewhere that simply acts as an image server, and you could have other LXD hosts that simply point to your kind of central image server, which is running the LXD engine along with all of the other LXD hosts that you have, and you can actually use that as a centralized store to download images from. Now, the difference with the LXD protocol is that this protocol is designed to give you kind of full control over the LXD engine. It's not specifically designed just for downloading or publishing images for your virtual machines on LXD. So it's a much more heavyweight protocol because it does have a lot more code, a lot more capabilities built into that protocol. And that's why for publicly available image servers that are just hosting simple images as kind of a read-only mechanism, that's why Simple Streams is a better designed protocol for that purpose. And you'll see when you actually start to dig into the LXD engine with the default remotes that are configured that the publicly available image server from the Linux containers project is actually using Simple Streams. So our next topic here is just some dev comments that I found on the Linux Containers discussion forum from one of the developers of the LXD project that talks about Simple Stream and the pros and cons between Simple Streams and the LXD protocol. Of course, one of the major limitations is just that you can't have private images on a Simple Streams server, whereas you can set them as private images on a LXD server. And also there's the performance mention here around the metadata or the index file becoming very large and could slow down or significantly impact the time that it takes to perform a search for images. And so that's just kind of some of the limitations of it there. In any case, our next topic is going to be searching for virtual machine images. So how do you actually find the available virtual machine images directly from the command line? Well, of course, you could go out to images.linuxcontainers.org, and there's a nice landing page right there that's formatted very nicely for viewing in a web browser, and you can use that to search for different images. However, if you're at a terminal or the command line and you want to be able to do a search against an image server, you can actually just use the LXC CLI to accomplish that. So you've got your LXD host running the LXD daemon, you've got the LXC CLI tool that you use to interact with it, and then you've got an LXD image server, most likely running simple streams out on the internet. And if you want to do a search, the first thing you want to do is actually find the remotes that you have configured, because if you don't have any remote image servers available, then you have nowhere to perform a search against. There are default remotes configured out of the box, but it's always possible that somebody could actually remove those default remotes from the LXD configuration. So the first thing you want to look at is what remotes do I have configured on this LXD server, especially if you're not the person that set up that server initially and did any configuration on it. So once you list your remotes, you'll actually find a list of remotes that are configured, and then you can use the LXC Image List command to perform a search against one of those remotes. And yes, the colon at the end of the list command is necessary because when you specify a remote in the LXC CLI tool, you do need to make sure that the remote name is suffixed with a colon at the end of it, just to indicate that you are querying a remote service. So one way that you could do this is to query the images endpoint, and that's one of the default remotes that's configured. That is actually a pointer to the images.linuxcontainers.org server, simple stream server, so that you can download images. There's also a default remote called Ubuntu that's configured because Canonical is the company backing the development of LXD. So of course they have a separate Ubuntu repository just dedicated to the latest Ubuntu releases. And something else I wanted to mention is that you can actually format the output from this command so that rather than displaying a kind of garbled table directly in your terminal, you can actually spit out either JSON or YAML formatted syntax, and then you can interpret that metadata coming from those images using other utilities. Like PowerShell, for example, is really great at reading dynamic JSON data. JQ is another CLI tool that's really great for querying JSON data. And so you can take that JSON data, feed it into some other utility that does a better job of querying JSON data and kind of sift through the list of images that are available. All right, so the next thing is going to be how do we pre-cache images on our LXD host? So normally when you use the LXC or LXC launch command line utility, you are going to create a new virtual machine. However, if LXD doesn't already have a copy of the virtual machine image that you specified, then it'll go out and attempt to download it for you. However, sometimes it's nice to be able to pre-cache the image as a separate step so that you don't have to allow the launch command to worry about downloading the image. The launch command can just focus on creating the new virtual machine and getting it up and running. So the images themselves are downloaded from the LXD image server, such as images.linuxcontainers.org, and then LXD actually caches those onto a storage pool. Something that's really nice is that you actually have the ability to specify a custom storage pool as well. So you don't have to just use the default storage configuration. You can actually configure LXD to store your images in a separate location, and we'll take a look at that in just a moment. But in order to pre-cache an image, we use the LXC copy command right here. One of the important parameters here is going to be --VM, indicating that you want a virtual machine image instead of a container image. And that's important because if you're creating a virtual machine, you can't use a container image in order to do that. So when you are grabbing an image from a remote image server, you do want to specify --VM. And you also want to specify local here at the end because that is going to be where you're copying it to. Remember that LXC works against remote engines. And so typically when you're using LXC, you probably are just going to be using it on the local LXD host. But in the future, when you start dealing with a much bigger environment and you have multiple remotes, you do want to be able to specify which remote you actually want to send that image to from the LXC CLI tool. So one way to specify an image is actually by using its unique ID, its hash that's generated during the creation of the images. So we specify the remote images and then a colon and then the unique hash of the image that we want to retrieve. Another option that we have is to use what's known as an image alias. So LXD supports image aliases that are basically more friendly names than having to remember this arbitrary list of characters right here for the hash, right? So we can simply say something like Ubuntu/2304. We could say Ubuntu 2204 in different versions of Ubuntu. Same thing for other Linux distributions. We could specify Alma Linux, Mint Linux, and what have you, whatever is available on the image server that you use when you do a search for an image using the commands in the previous slide to do an image list command. Now, if you want to specify a custom storage pool and volume, the way that we do that is actually by editing the configuration of the LXD host itself. We specify this option called storage.images_volume, and we set the value of that configuration option to the storage pool name and the volume name, a custom volume that we would have to pre-create on that LXD host, and that is what allows us to specify the custom storage pool that we want to use when we download images from an LXD image server. All right, so our next topic here is how we register or add a new LXD remote image server to our LXD host. So you aren't probably going to have to do this a lot if you're just using publicly available images, but if you want to register a third-party Simple Streams publicly accessible image server, such as the Ubuntu Minimal LXD image server, you can do that by using the LXD Remote add command. We need to specify the protocol here, which is either going to be Simple Streams or LXD, and then we specify a unique name for the remote. That's just a unique name for you to identify that particular remote as, so it doesn't really matter what you specify for that value. But the important parameter here is the URL, and you'll get the URL from whatever image server documentation that you want to register. Now, I did some searching out there for publicly available image servers, and the only one that I came up with was the Ubuntu Minimal LXD image server, and the URL for that is right down here, and that's a Simple Streams server, so we would just register that using the Simple Streams protocol. We could give it a name like Ubuntu-Minimal or just Minimal for short or whatever you want to, but that's how we can register a new image remote with the LXD engine. All right, one other cool capability with images is that you can actually publish a virtual machine disk, a root file system, as a custom image on your LXD server. So in this case, we're not dealing with image servers at all. We just have a LXD host. We create a new virtual machine on that LXD host using one of the base images available on the images.linuxcontainers.org image server. And we can install whatever software, we can make whatever configuration changes that we want to, and then we can essentially take that virtual machine and repackage it as an image that we can then redeploy. So if you need to pre-install a bunch of software and get everything set up on a particular configuration for your special servers, then you can do that by taking a VM and doing a publish operation on that VM, and that will register that virtual machine as an image. It'll actually take a copy of that virtual machine, turn it into an image, and then register it with your LXD host. To do that, we just use LXD publish. It's not under the image context, it's just LXD publish. Then we specify the name of the virtual machine, and optionally, you can specify a remote that you want to publish that image to as well, although you don't have to do that because it'll just publish it to the local LXD host that you are interacting with from the LXD CLI. All right, so it's time to put things into practice. So some of the common operations that you'll want to practice hands-on with your own LXD host would be things like pre-caching or downloading an LXD virtual machine image from the image server. You could also publish a custom image from a virtual machine that you create, pre-install a bunch of software, create whatever config files you need to, package that up, publish it as an image, and then be able to redeploy. You could also delete images from the local cache on your LXD host if you need to free up disk space and you have a bunch of images taking up space on your disk, you could delete those. Also, you could configure LXD to cache images in a custom storage pool and volume. So we'll take a look at that. And then finally, you could launch an LXD VM from a custom image that you published in the second item in this list right here. All right, so it's time to jump over into our system here. So I've got a LXD host here, and I've already run LXD init right here. And so for starters, let's just go ahead and explore the different images available on the host right now. So if we do LXD image, let's do LXC image rather. You can see a list of subcommands here, and all we want to do is just list images. So if we do LXC image list right here, you can see that we don't have any images cached on our local system. However, let's take a look at some images available on one of the remotes. So first of all, the question is, well, what remotes are available? So we do LXC remote list. And as you can see, we have the default remotes registered with LXD right here. So we have the images server. That's kind of the main image server available. But then we also have an Ubuntu endpoint here that we can query images from that's also using simple streams. And there's also an Ubuntu daily builds as well. So if you're looking for a cutting edge image of an Ubuntu operating system, you can go to that Ubuntu daily and find a cutting edge version of Ubuntu Linux. But most of the images you'll probably use are going to be on this images endpoint here. So what we'll do is just say LXC remote list images : So what I actually meant to do here was LXC image list, and then we'll specify our remote, which is images : and then we'll let this run for a second. And as you can see, we get this huge table of images that's available. We've got Debian, Arch, Fedora, Devuan, OpenSUSE, we've got Rocky Linux, Kali Linux, and there's just a whole bunch of images here, right? And you can see on this second column that we have some are container images, some are virtual machine images. It tells us the size of the image. It also tells us the unique hash. So if we want to reference a specific image by its hash, we can just grab that as well. We can also see the date that the image was published. So if we're looking for a newer image, we can just check out what the newest image is in a particular family of operating systems here. And we can also see the CPU architecture. So AArch64 would be an ARM 64-bit CPU, such as a Raspberry Pi device or an Odroid device using an ARM 64-bit CPU, and then x86-64 is reference to Intel and AMD 64-bit compatible CPUs. Now, this is kind of hard to read here. So you can see we've got this huge table. So I'm going to bump the font size down a little bit, and that's more what it's supposed to look like here. Now, this far left column right here is empty for the vast majority of images here. And that's because if we scroll all the way up to the top right here, we're going to start to see a list of aliases for some of these images. And it looks like that's actually at the end of my buffer there. So what I'm going to do is apply a filter. So we're going to say LXC image list on our images server, but we're going to filter for Debian images only. So we can actually type a filter at the end. And as you can see in this far left column here, we actually have what's known as an image alias that you can use to reference an image rather than using the unique hash right here. So if you were looking for, Debian version 12, for example, and you were looking for a virtual machine image, we can kind of filter out all these container images here. And we're going to look for basically virtual machine 64-bit. And it looks like this one right here is actually the right image. So we could take this image and we could either reference it by using this unique hash here, or we could reference it by using Debian/12/cloud. And there's actually additional aliases on each of these images as well, anytime that you see that there's more available. So sometimes there's multiple aliases, sometimes there might only be one alias for an image, but if you want to see a list of all the aliases for a given image, like let's grab maybe this Debian 11 cloud image right here, I'm going to grab the hash, but then what we can do is say LXC image info, and then do images : and then specify the image that we want to get the info for. And as you can see right here under the aliases property, there's actually 4 different aliases that we can use to reference Debian 11, also known as Bullseye. And we can even be more explicit with the CPU architecture that we want as part of the alias if you so desire. But you don't have to. You could just use something like Debian 11 Cloud or Debian Bullseye Cloud, whatever really suits you. So you can use the info command here to get some details about a specific image using its hash here. All right, so now let's go ahead and try to actually download one of these images. So what I'm going to do is just do a list for Alpine Linux because it's a pretty lightweight version of Linux. And so what I'm going to do is look for a 64-bit version of the virtual machine image. So it looks like we have Alpine Edge Cloud here. So I'm going to go ahead and copy that alias. And then we'll just do an LXC copy command. And what we want to do is specify the remote in the source and specify the destination that we want to copy it to, which is just going to be local. So we'll do LXC copy, specify the images server, paste in the alias for that image, and then we'll just reference the local remote, which is technically a link to the local Unix socket. And it looks like we also need to specify --VM here as well. And I just realized I'm missing the image copy command here. So we'll go to image copy, and that should be the right command that we have here to copy that image from the remote onto the local system. So now that we've cached that locally, we can do LXC image list against our local system. And as you can see, we've got a copy of Alpine Edge, 64-bit for a virtual machine, and that is on our local system. So now we can use that to actually launch a brand new virtual machine. So we could use the fingerprint if we wanted to. And so we could do an LXC launch config security secure boot equals false. And then we'll specify the image server, which is images : that hash right there. And then we'll specify a VM name like A01. And it looks like, oh, we're getting an error here because I didn't specify VM. We'll do LXC launch VM, and that'll use the image that we already downloaded and create a new virtual machine disk from it. And so now we've got a virtual machine running from that pre-cached image. All right, so the one other thing that I wanted to check out is how to actually create a custom storage pool and then tell the LXD engine that you want to cache your images to that separate location. So by default, if we go under the var snap LXD, and then I think it's under common, and then LXD again, and then under images here, this is where you are going to find the default image location for any images that are cached locally. So right up here, you can see the fingerprint of the Alpine Edge image here that we downloaded from the images server, 5B81. And right down here under var snap LXD common LXD images, we have 5B81. So this is where those images are currently being cached. However, we can create our own custom storage pool instead, and we can specify a volume that we want to store our images under as an alternative. So what we're going to do is just create a new storage pool, and I've actually got a separate video that I created in this series already on storage pools, so hopefully you saw that one. So we're going to go into the storage context. We're going to create a new storage pool. We're going to give it a name like my storage, and we're going to use the dir driver, and we're going to set the source equal to /data/LXD files. And that doesn't exist yet, so we're going to get an error. So let's just do a make dir --parents /data/LXD files and rerun the storage pool creation command. And so now we've got a new storage pool. So now let's go ahead and create a volume under there. So we'll do LXC storage volume. And we want to use the create command here to create a custom storage volume. So we'll do create. And then we're going to specify the type of file system here. So that's just the default. And then we also need to specify the pool and a new volume name and optionally a size as well. So we'll do a create. We'll say my, what do we call this? My storage. And we'll give it a name like my volume 01. And so now what we can do is actually customize the configuration of the LXD engine to use this volume as the storage location for images. So what we're going to do is say LXC config edit, and that will configure the LXD engine itself. And so now under the config section here, we're just going to indent with 2 spaces and say storage dot images volume. And the value of this is going to be pool/volume. So we'll do my storage /my volume 01. We'll do Control O to write the file, Control X to exit. And if everything checks out and the pool and the volume exist, then we shouldn't see an error here. And so now, if we try to download a different image, let's do a search for Alpine image here. Actually, I'm just going to do a copy on 3.18 and download that locally here. Let's go ahead and run that. And so now what's happening is it's going to grab this different version of Alpine. So previously we cached the Alpine Edge, but this time we're grabbing Alpine 3.18. It says image has been copied successfully. So let's verify that under our custom volume. So we're going to go under /data /LXD files, and you'll see that we have this images, actually this custom directory right here that contains our volume. So we go under custom, and then we have the my volume 01 directory. It's prefixed with default for some reason, and I'm not entirely sure why that is. But you're actually going to see that our operating system images are now being cached under this custom storage pool that we created. So this is really nice because it gives you the flexibility to actually move your image cache from the default ZFS storage pool to an alternative location. So maybe you attach an extra data disk to your host and you decide that you want to store your image data there. You can do that by simply changing the configuration of your LXD engine to point it to a different storage pool and volume, and that data will start to get placed there instead of the default location. So the last thing that I want to take a look at here is just how to delete an image. If we do LXD image list on our local system, we now have two different images here. We've got Alpine Edge, that's the first one that we cached, and then we've also got Alpine 3.18. And so right now we're not using Alpine 3.18 because we only launched a VM from Alpine Edge. So let's take this hash and we'll just do an LXD image delete command right here. And when we do the delete context here, we just specify the remote that we're deleting from. In this case, it's just local, so we don't need to specify it. And the image, either using an alias or the hash of the image. So we'll do LXD image delete, just paste in that unique hash for the image, and we don't get any results. But if we list our images, you can see that that image has now been removed from our local cache. And if you want to validate even further, you can go list the files in the image cache that we specified for our custom storage pool here. And you can see that that image has now disappeared from the results where we previously saw it showing up right here. All right, so that's all I have for images for the time being. There's a lot of other interesting topics in LXD though, so I hope you enjoyed this one. Please like this video, subscribe to the channel, share a link with your friends, family, and professional contacts, and we'll see you in the next video. Take care.